Okay guys, so today we're going over area of a sector and arc length of a circle, and you have to get yourself familiarized with parts of a circle first. So right here we got the arc, which is just a segment of a circle right here, from the outside, sort of like the circumference, like a part of it. That's the center, and this is the radius. And right here, normally we would have an angle during problems, and that would represent your data, which is in the shape of that. This is shaded area is a sector, which is what normally you'd find the area of in this section. This is the center, and this is a chord. This is another segment. Okay, so how do you find the area and arc length? So arc length, you have your angle right here, which is your data, and this would be your arc length. So for data in radians, the equation would be arc length equals data times radius. For data in degrees, it'd be arc length equals data over 360 times 2 pi r, which is pretty much circumference. Area of sector, you are trying to find this shaded region. For data in radians, you would need to do area equals 1/2 times data radius squared, and for data in degrees, it's area equals data over 360 times pi r squared. So we should keep that in mind when we do problems. When you see a circle problem like this one, it says the circle has center O and radius 3.9 centimeters. So we got this center right here, center O. This radius is 3.9, and it's got data 1.8, so like your angle right here. Points A and B lie on the circle, and angle AOB, which is AOB, is 1.8 radians, so your data. And find arc AB, so we're trying to look for this arc right here. And if we look back at our equation to get arc length, all you have to do is multiply data times radius. So it would be 1.8 times 3.9, and that would give you approximately 7.2.02 centimeters. Find the area of the shaded region. So right here we're trying to get this shaded region, but we know how to get the area of this sector, which would be area equals 1/2 data radius squared. So we would have to do 1/2 times 1.8 times 3.9 squared, which would give you 13.689 centimeters squared. And to get the area of this shaded region, you get the area of the whole circle, which everybody knows that area equals pi r squared. So that would be 47.75 if you multiply 3.9 squared times pi. And so you would subtract those, and you would get the shaded region. So subtract this number from this, and you would get 34.07 centimeters squared as your area of the shaded region. Okay, so those were pretty simple. We can continue on to more examples. Okay, the diagram below shows a circle center with center O with radius r, and the length of arc ABC right here is 2 pi centimeters, and angle AOC equals 3 pi over 8. And it says find the value of r So to find the value of r, you would pretty much use the equation, but you'd kind of go backwards. So you'd get the arc length that you have. So it'd be 2 pi divided by your data, because as we see here, it's arc length times data times arc length equals data times radius. So 2 pi divided by your data, which is 3 pi over 8. And that would give you a radius of 5.33 centimeters. Find the perimeter of sector OABC, so this sector, and we know the equation for arc length, and we have the arc length. And to find the perimeter, all you have to do is pretty much get the answer that you have here, which is your radius, and you have 2 radiuses here, so you'd multiply that by 2. And then add your arc length. And that would give you a perimeter of 16.94 centimeters, like that. And then find the area of sector OABC. Area of a sector, we all know it's 1/2 times your data, which is 3 pi over 8, times radius squared. And that would give you 16.73 centimeters. Okay. So our last problem, the diagram below shows a circle of radius r and center O. The angle is AOB, and you don't have either the data or the radius. So for this problem, we'd have to start with the equations and kind of do a little bit of algebra here. So you have arc length equals data times radius, and you have area equals 1/2 data radius squared. So here essentially what you would do is divide the area by 1/2. So essentially it would give you 2a equals data radius squared. And once you do that, you you have to divide 2a by r squared, and it would give you data like this, single out data. And when you have this equation, you can single out data as well by dividing arc length by radius, and that would be your data. So these two essentially equal each other. So you would put these equations as such: equals arc length over radius. Okay, once you have that down, you can pretty much just plug in. Now that you have your arc length and your area that you can use to get your radius. So using this equation, we can have 225, multiply that by 2, over radius squared equals arc length, which is 30, over r. So you would essentially get 450 times r, you cross multiply, equals 30 r squared, multiply those two, and then when you divide 450 by r squared, you get 450 over r equals 30. Because when you divide these, 1 r cancels out. Alright, so here you have r, and just get to the radius real quickly, and the radius would equal 15. Okay. And once you have your radius, you can easily find data, just plug it in back into your arc length equation. So you have your arc length equals 30, and then you can just plug in radius 15 to get data, and your data would equal 1.6. So yeah, that's pretty much it.